So as you've probably seen in our videos, we do an awful lot of fault finding jobs. We always get asked a lot of questions on our videos about how we approach this sort of job. So the first thing is to always listen to what the customer says, listen to the symptoms and the things that they've said to try and give you an indication as to what might be the cause. Next thing is to start doing an insulation resistance test on the circuit, but first you want to unplug everything on that circuit, otherwise you'll start getting interference on your readings. So you want to make sure the entire circuit is clear before you start insulation readings. Obviously every fault is different, but in theory you'll have either one or all cores that have probably got a dead short somewhere, and this will be your first clue as to what the issue might be. We generally always look for outside accessories first, particularly if the weather's been quite poor at that time. You want to be looking for water ingress in lights or sockets, etc. But if there's none of that, then you start looking at the internal circuitry. If you've had no luck so far, the next thing would be to start splitting the ring circuit so you can start investigating each individual leg. Now normally you look for a logical cable route and you start somewhere around the middle of the ring circuit and you take the socket apart like this, so you've got two separate legs. You then carry out insulation resistance on all three cores on both of those legs, and in theory you should have one good side and one bad side. I'll have a drawing, so let's explain it in that form. So here you have a basic layout of a house, very rough of course, and there you have a numerous amount of sockets that are scattered around. The amount of sockets will always vary, but this gives you a gist, and then you can see the consume unit in the middle of the hallway there. So you'd have a look at the assumption of the layout and then try and start somewhere halfway. So I'd start somewhere around here and separate the ring there. The theory is you'd have one faulty leg somewhere. So in theory you'd have one good side and one bad side, as I explained before. So say this side was good and this was the bad side. You'd then carry on and start and pick another central point somewhere around here and separate again. And you continue to do this until you're left basically between 2 points of the ring circuit in which you've hopefully found the faulty leg of cable. If you are fortunate enough to find it between 2 points, then hopefully it can be disconnected. If it's like our recent squirrel video, it may be fairly obvious where the damage is, in which case you can repair that leg of cable and get the whole circuit back working as a ring again. Sometimes it's not that fortunate though, so it may be a case of disconnecting that particular part of the circuit and using it as two radial circuits and downrating the breaker to a 20 amp. But in theory, if you've removed that faulty section of cabling, you should repeat your insulation resistance test and you should then get completely clear readings throughout the whole circuit. Then you know you've sorted the problem. Once that's done, everything should go back together again and the circuit should come on. There should be no issues. This was a very quick guide, and I know there's loads of variables on this, but hopefully that's given you a rough guide in short, and if you've got any other questions you can just drop us a DM.